Okay, so you just read the question. We have a centripetal force problem. There's a car that's 2,050 kilograms, and it's trying to round a corner. And the corner has a radius of 20 meters. The coefficient of static friction was also given. It was 0.7. So we're trying to find out how fast can the car go without slipping. And so that would be our tangential speed right over here. So I've kind of drawn what the circle would look like from an angle. If the car is here at this position, then we know that gravity is pulling downward. Normal force, that's the road pushing back upward. And then if we're going in circular motion, then we have to have some centripetal force pointing towards the center. For this problem, static friction is acting as the centripetal force. So before we go further, let's take a look at the normal force and the force of gravity. From other force problems, we know if we sum up the forces on the y-axis, we would have Fn minus Fg. There's no motion vertically, so we'll make this equal to 0. And if I just look at this here, we can see that Fn equals Fg, and we know that Fg always equals mg. Therefore, the normal force equals mg. So we'll need to use this in just a minute. If we go back to our circular motion part over here, we know that static friction is acting as our centripetal force. So we can use any equation that we have for static friction and for centripetal force and set them equal. So our equation for static friction is mu s times Fn, and because we're looking for our tangential speed over here, I'm going to pick the equation for centripetal force, Fc equals mvt squared over r, the one that has our tangential speed in it. So I'm just going to take this stuff, put it in right here, and I'll take this stuff and put that in right there. So if we rewrite this, we have mu s times Fn equals m vt squared over r. So now I just want to take and rearrange this equation and solve it for, we'll first do it for vt squared. So what I can do is multiply by r and then divide by m. So I would end up with mu s Fn times r divided by m. But remember, right over here we just found that the normal force is equal to mg. Normal force equals mg. So I can do one more substitution. I can take this and put that in place of the normal force. And so now I would have vt squared equals mu s mg r over m. And since m is upstairs and downstairs, it just cancels. So the equation that we're going to use for this is Vt equals the square root of mu s gr. Right, and this will give us our answer. So we'll just put all the numbers in. So the square root of 0.7 times our 9.81 meters per second squared times the radius, which is 20 meters. Calculator does all the work, and we get 12 meters per second. And if you notice, it didn't even matter, let's make this red, it didn't even matter what the mass of the car was, right? The car mass cancels out, and so this would be the top speed for any car that has the same coefficient of static friction between its tires and the road. So mass of the car doesn't matter. The mass was given, so you could have done this in multiple steps, but this is the most direct route to get that one equation for this problem. And that's it. I'll see you in class.